Let's talk about one of my favorite subjects: geology.
Let us not do that. Geology is so terribly boring.
Please don't make up your mind too quickly. When you spend a little time looking into geology, I think you'll find that it's not boring at all. Geology is not just looking at a bunch of rocks. Studying geology can be awesome.
And these massive rocks can also be beautiful, whether you are looking at geological structures below the Earth's surface, or with amazing water features above ground. They can be very impressive just standing there all by themselves, and when you look more closely at them, you might wonder how they got their unusual designs.
Some people will tell you these structures took very long periods of time to form, like millions or billions of years. But let's look at the scientific evidence to see if they really do need this much time. Or if they can form much more quickly if the conditions are right.
Let's start by looking at one example of a dramatic difference in beliefs about how old these rocks may be. One of the bottom layers of rock, which is called Precambrian basement rock, was formed from hardened lava. In it, we can find tiny zircon crystals that contain the radioactive elements, uranium and thorium. As the uranium and thorium decay, other elements and helium are produced in the zircons.
The radioactive elements cannot escape from the zircon crystal, but the helium can diffuse through it. So the age of the crystals can be estimated by either measuring the amounts of the radioactive elements, or by how much of the helium has been able to diffuse, or both. Evolutionists have measured those other elements and concluded that the rocks are about 1.5 billion years old. But the helium should not be ignored. The helium diffusion measurements indicate that the same rock is only about 5,700 years old.
That certainly is a very big difference between the two methods. Congratulations, you have succeeded in arousing my curiosity. Obviously, you believe the 5,700-year age of the rock. What is wrong with the radioactive dating calculation? Both methods have assumptions. But the one that may be most significant is the belief that the radioactive decay rates for uranium and thorium have been constant since the Earth was formed. Recently, Italian researchers found that the nuclear decay of thorium was accelerated by a factor of 10,000 during a 90-minute experiment.
So, you see, there are reasons to believe that the rocks may only be a few thousands of years old. But the question remains whether they can form that quickly. To answer that, let's look at a recent major geological event. One for which we have a lot of data. Let's examine the eruption of a volcano in Washington state in 1980. The eruption of Mount St. Helens.
There have been many volcanoes that have erupted around the world. What is so special about Mount St. Helens? The main advantage of Mount St. Helens is that it happened in the United States. That has made studying it easier. And the information we have about it may be more complete than other volcano eruptions. Mount St. Helens is the deadliest and most economically destructive volcanic event in United States history. As a result of its eruption, 57 people were killed. And there was extensive damage. 250 homes, 47 bridges, 15 miles of railways and 185 miles of highway were destroyed.
To give you an idea of the power it released, the mountain literally blew its top. The elevation of the mountain summit was reduced from 9,677 feet to 8,363 feet. It destroyed over 1,400 feet of the mountain top. When it did that, it left a horseshoe-shaped crater that is over a mile wide, as you can see in this photo of it.
In only a few years of time, the Mount St. Helens eruption produced features similar to some that evolutionists claim required vast amounts of time. So, let's look at some specific examples of quickly formed geologic structures caused by this volcano.
Mount St. Helens eruption is usually said to be on May 18, 1980. At that time, an earthquake triggered what some have described as the largest observed landslide in history on the north side of the volcano. As this rock slid toward the base of the mountain, the internal pressure exploded out of the north face. The ash, rocks, and gases formed a cloud that expanded northward at speeds up to 600 miles per hour.
It took only between 5 and 9 minutes to destroy everything and kill all living creatures in a 19 by 12 mile blast zone. That was 230 square miles of total devastation. Over this area, it created deposits of flowing ash, mud flows, steam water, and falling ash that were up to 600 feet deep across the Toutle River Valley. For the next 2 years, Spirit Lake swelled on Mount St. Helens behind a 150-foot-high natural debris dam. On March 19, 1982, another explosion on the volcano melted a massive amount of snow and ice which slammed into Spirit Lake, overwhelmed the natural dam, and became a catastrophic mudflow, scraping out a canyon with side canyons up to 140 feet deep through the 2-year-old volcanic deposits. This canyon was carved out in a single day.
The steep sides of the canyon reveals many sedimentary layers that were deposited with the 1980 eruption. The layers can be seen to be in several groups. One group is known to have been deposited in minutes, while others took a few days. Some researchers have described this canyon as looking like a 1/40th scale model of the Grand Canyon. But we know that this canyon was formed very quickly.
Although the canyon on the North Fork of the Toutle River was carved in relatively soft sediments, a similar explosion and mudflow 2 months later, in May 1982, cut a 100-foot deep Lewitt Canyon through bedrock, and Step Canyon through 600 feet of lava layers. These canyons might appear to some people as having been formed over long periods of time from slow erosion by their small streams. But we know that, in the words of Dr. Steve Austin,
the stream does not cause the canyon causes the stream.
There are quite a few places around the world where fossils of upright trees can be found in different rock layers. I have heard evolutionists interpret this as resulting from multiple forests, which grew on different layers over periods of thousands of years.
Some scientists, however, believe that these fossil trees tell a different story. The evidence tells them that the trees may have been pulled up out of the ground by a flood. They would then float on the water. Winds and wave action would strip off bark, branches, and most of the root structure. Eventually, the tree would become waterlogged and sink. The remaining root structure would be the heaviest and sink the fastest, so it would land on the bottom looking like it was standing upright. Flood sediments would collect around the sunken trees, fossilizing them.
That is very similar to what has actually happened at Mount St. Helens. Volcanic activity stripped the forests from the slopes adjacent to Spirit Lake and created an enormous log mat. It is made up of millions of prone floating trunks. With time, the log mat got smaller, indicating that the trees were gradually sinking to the lake floor. Many trees floated in an upright position, with a root ball submerging the root end of the trunk, while the opposite end floats out of the water.
Scuba and sonar surveys of the lake bottom showed that many of these trees sank to the bottom in both the prone and upright positions. The survey estimated that 19,000 or more upright stumps existed on the floor of the lake in August of 1985. The trees were randomly spaced, not clumped together over the bottom of the lake. The tree stumps also sank and were deposited at different times, placing them in different layers of sediment. This made it look like they could have been the remains of forests that grew at that location. If found as fossils in rocks, evolutionists might interpret these trees as multiple forests, which grew on different layers over thousands of years. But we know that all of this happened much more quickly than that. It only took about 5 years.
Another lesson from Mount St. Helens is about how coal may have been formed. We can find large coal fields worldwide today. Evolutionists believe that a long time ago, the Earth was covered by swamps that were filled with giant plants. Then, about 100 million years ago, the plants died and were covered by water and dirt. As dirt, rocks, and other stuff continued to form layers on top of the dead plants, it provided the pressure and heat to slowly turn the plants into coal deep underground. They believe this required about 1,000 years to turn the plant remains into each inch of coal that we see today.
The scientists studying Mount St. Helens don't see coal being formed yet, but they do see peat accumulating that could make coal. peat is the remains of dead plants. As we previously mentioned, the enormous log mat floating on Spirit Lake has lost its bark and branches by the abrasive action of wind and waves. This bark and these branches became waterlogged and sank to the bottom of the lake. Scuba divers have found a layer of peat on the lake bottom that is several feet thick. The Spirit Lake peat looks like it could form coal that is very similar to the coal beds of the eastern United States, which were made from tree bark. All that is needed is for it to be buried and heated to change the Spirit Lake peat into coal. Today, commercial companies turn sawdust into charcoal briquettes by heating them for about a week. So, at Spirit Lake, we may be seeing the first stage in the formation of coal.
From this example, we can see that the very large amounts of coal that we can find around the world today did not require extremely long periods of time to form. They could have been formed in years or tens of years.
Mount St. Helens has proven that some geological features can form rapidly. Now, let's briefly consider the event that caused most, if not all, of the geological structures that we see throughout the world.
That event was what many people call Noah's flood. But it was much more than what we usually think of when we speak of a flood. There was a lot of water, to be sure. The Bible described it as raining for 40 days and nights, and that water covered even the highest mountains. But before it happened, God vowed that He would destroy the earth. Just before it started raining, the Bible says that God did something unusual. He burst open the sources of the watery depths. That is a rather curious statement. It is not clear what that really means.
It may be describing the breakup of the Earth's crust beneath the oceans. As one writer describes the results of sophisticated computer models depicting this event, quote, "The overlying crust stretched and thins, allowing the magma to break through very rapidly along the linear belts, stretching thousands of miles along the ocean floor. As this molten material came into contact with cold seawater, it generated a long, linear geyser of superheated water ejected into the atmosphere," unquote. That was apparently the initial event that set into motion all that would soon happen.
It appears that most of the major natural catastrophes that we experience today, such as earthquakes, tsunamis, volcanoes, intense storms, and massive ocean waves, were occurring nearly simultaneously, but on a much more massive, global scale. In addition, we believe that all the inhabited area at that time was combined into a single large continent called Pangaea. During the flood, Pangaea was split in pieces, which then drifted and formed the smaller continents that we have today. There were some of these plates that collided and formed mountain ranges. Unseen, beneath the waters, a new ocean floor was formed. The devastation of all of these catastrophes happening together is unimaginable. The result was the world of that time was destroyed.
It is difficult to imagine the violence of the natural catastrophes that occurred during Noah's flood. Since we have discussed the devastation caused by Mount St. Helens eruption, let's compare it to volcanic activity during the flood. In addition to the local geological effects we already discussed, Mount St. Helens spread ash over 22,000 square miles. This included parts of the states of Washington and Idaho. This was a major event.
However, it was dwarfed by the volcanic activity during Noah's flood. We know of at least 6 supervolcanoes that erupted near the time of the flood. One of these was the Yellowstone supervolcano. Yellowstone National Park is the dormant caldera of that massive volcano. Its caldera is about 30 by 45 miles across and hundreds of feet deep.
This diagram might give you an idea about how much larger and more powerful Yellowstone was compared to Mount St. Helens. Yellowstone's ash fell over nearly 1/2 of the continental United States. And, as we said, there were at least 6 of these supervolcanoes that erupted around that time. In addition, there were probably hundreds of Mount St. Helens-sized volcanoes that also erupted.
Coupling the volcanic eruptions with the gigantic tidal and wave actions, the shifting continents, and unimaginably violent sea storms, you might be able to imagine how thousands of feet of sedimentary rocks and other geologic features formed.
We've found that all of the Earth's features around us could have been formed in the past few thousands of years. But the question still remains, how old is the Earth? We already showed you a problem with the standard radiometric technique. But there are quite a few other ways you can also estimate how long the Earth has been around. Most of these approaches give a young, estimated age for the Earth. We don't have time to explore each of them, but let's consider one more. Let's talk about carbon-14.
Carbon-14 is a radioactive element. It is formed when a cosmic ray hits a nitrogen molecule.
It very quickly combines with oxygen in the atmosphere to form radioactive carbon dioxide.
The radioactive carbon dioxide is absorbed by plants to make radioactive grass. When a cow eats the grass, it becomes radioactive too.
Then, when the cow is turned into hamburgers and we eat one, we also become radioactive.
Eventually, all living organisms have radioactive carbon-14 in them. When they die, they stop getting more carbon-14, and the carbon-14 that is in their bodies begins to decay.
So, we can estimate how long it has been since a once living creature died by measuring how much carbon-14 is still in their tissues. Since carbon-14 decays relatively quickly, it can only be used for organisms that died less than 100,000 years ago. Anything that is older than that would not have any measurable carbon-14 left.
Evolutionists claim that diamonds and coal are millions or billions of years old. Yet, we have recently found carbon-14 in both coal and diamonds. We have also found it in other organic materials that are supposedly millions of years old. This includes petroleum, gas, and dinosaur bones. If you follow the science, it tells us that these items are not that old. They must be much younger than evolutionists claim. No one can prove how old the Earth is. But there is no evidence that requires it to be millions, or billions, of years old. In this presentation, we have shared some good reasons to believe that it is only a few thousand years old. We have shown how the geological features we see all around us could have formed relatively quickly. When carefully studied, geology is a friend to those of us who accept that God created the heavens and the earth exactly the way the Bible tells us He did. So, the next time you are driving along the highway and you notice rock layers that are curved, you can think, this is an example of rock layers that were still moist and pliable following Noah's flood, so they bent instead of broke. Or the next time you visit one of the magnificent national parks around the world and see some of the intricate geological features, you can remember that. These must be very young, otherwise, the designs would surely have eroded away.
When you look at a sparkling diamond, you can visualize carbon-14 atoms adding to its wonder, since it's only thousands of years old. Our world, our universe, is fantastic beyond description. To God be the glory.